Now we are going ahead with very important session, immediate inferences. That is the second stage in analytical reasoning. I told you now. So it's very interesting and of course at the same time confusing also. So I will clear all your doubts and you will be getting many doubts for sure. You will be getting many doubts for sure. What is this immediate inferences? All these things we will discuss in detail. Before that one, can we just sum it up whatever we have discussed so far in syllogism? Now, what is the meaning of syllogism? Syllogism is nothing but inference or deduction from any given statements. What other statements can be extracted is what the meaning of syllogism. In syllogism, we do have four types of statements. We call them as propositions. So proposition is nothing but a sentence which makes a statement having a subject, predicate and relationship between subject and predicate. We do have four types of statements: universal positive propositions represented with A and universal negative propositions represented with E, particular positive propositions represented with I, particular negative propositions represented with O. So universal positive propositions, entire subject will be considered in a positive sense. So example being given as all white is black and it is represented with A, already we discussed. And universal negative propositions, so it is represented with E, where entire subject will be considered in a negative sense. So that is the reason it starts with no, and example being given as no white is black. Next one, particular positive propositions. Particular positive propositions means a part of a subject will be considered in a positive sense. So it is represented with I, it starts with some. So example being given as some white is black. So finally, particular negative propositions. Again a part of a subject will be considered in a negative sense. It is represented with O, it starts with some not. So some white is not black, right? This is what we discussed. And then whenever we need to solve the problems in syllogism, there are two variations, and in two methods we can solve it. One is Venn diagram method, that is the base method, and another one is the analytical method. From Venn diagram method only this analytical method being derived. It is nothing but a formula method. So formulas, once you learn the rules, regulations and all, so in analytical method it will be easy for you to solve the problems. Here we are going ahead with analytical method because if you learn analytical method rules and all, initially it may take time, but while solving the problems within 10 to 15 seconds most of the problems you can solve. Suppose the problems are 3 statements or 4 statements like that, it may take 30 to 40 seconds time, not more than that for sure. So learn analytical method, and I already told you, if you know Venn diagram method to some extent, keep it aside, just follow me and all my instructions, then see, once you learn it, then see which one is better. But of course I am going to give you the concept of Venn diagram method also, how to solve the problems and all, and also from Venn diagram method how it is being extracted in analytical method. So in analytical method what we have, we do have 3 stages to solve the problem. One is rule based one, second one is immediate inferences, third one is complementary pair. In order to solve the problem in syllogism through analytical method, you need to check all the 3 stages: rule based one, immediate inferences and also complementary pair. Then only finally we need to conclude the answer. Are you getting? So in solving the problems under analytical method, first and foremost rule is the statements must be properly aligned. What is the meaning of proper alignment? What is the meaning of proper alignment? There must be a common term. In addition to that one, the common term must be predicate of the first statement and subject of the second statement or last statement, which will be eliminated in the final conclusion. So you won't see common term in the final conclusion. For subject of the first statement as the subject, predicate of the last statement as the predicate, based on 6 rules. What are all those 6 rules? What is A plus A plus E, I plus A, I plus E, E plus A, O star, E plus I, O star. What is O star? O reverse. Subject and predicate of O will be reverse. But if the statements are not been properly aligned, what else we can do? So we can interchange the statements or we can convert the statements to make proper alignment. Remember, if the statements are properly aligned, there must be a common term. The common term must be predicate of the first statement and subject of the second or last statement, and based on 6 rules we need to find out the answer or solution. But in case if the statements are not been properly aligned, what else you can do? You can make proper alignment by interchanging any one of the statements or converting any one of the statements or applying both, based on which finally you need to find out the conclusion. So till now you have interchanged the statements and we have find out the answers, right? So we have seen many examples whenever it is not been properly aligned, by interchanging the statements we have find out the answers. In immediate inferences, what we are going to do is, from a given single statement, what other statements can be extracted. This is what we are going to find out. From any given single statement, what other statements can be extracted. This is what we are going to find out. What does that mean? What does that mean means, say that suppose we are taking A statement. So can A be converted into A? Conversion means, say that all white is black is there. Can we do that all black is white? Can we say all black is white, whether it is true? These things and all we are going to find out from A statement. So we are finding out all black is white is true or not, and from same A statement can we tell whether some white is black is true or not, or some black is white is true or not, some white is not black is true or not, some black is not white is true or not, no white is black is true or not, or no black is white can be derived from A statement or not. All these things from a given single statement we are going to find out. Are you getting? So in immediate inferences, from a given single statement, what other statements can be extracted? This is what we are going to find out. Now, immediate inferences are again further divided into two, or bifurcated into two: implications and conversions. Implications and conversions. In implications, a same subject and same predicate should be there, and in conversion, subject and predicate of that statement will be reversed, or subject and predicate interchanges. Always remember, immediate inferences are again of two types: implications and conversions. So implications means a same subject, same predicate must be there. Sir, what does that mean? Means if you say that all white is black, can I say that some white is black is true? Can I say that some white is not black is true? Can I say that no white is black is true? This is A statement. Now we are taking I, E, O statements with the same subject and same predicate. So whether those statements can be derived from A statement. That is what here implications. So conversion, subject and predicate interchange, right? So what we are going to check, when all white is black is there, can we tell all black is white is true? Can we tell some black is white is true? Can we tell some black is not white is true? Can we tell no black is white is true? That is what conversions, where subject and predicate will be interchanged. Now each individual statement we will consider. We will see the possibilities, which and all statements will be true and which and all statements won't come into picture, or which and all statements are wrong. All these things we will discuss in detail. Clear? So individuals, from any given individual statement, from any given single statement, what other statements can be extracted is what the meaning of immediate inferences. In immediate inferences, further divided, bifurcated into two, that is implications and conversions. Implications means same subject and same predicate must be there. Conversions means subject and predicate will interchange. Here many doubts you will be getting for sure. If I say some white is black, can I tell some white is not black is also true? Can I tell that? Many of you will be having this doubt, right? So I suppose 90% of the people will say that yes, and that we will prove that it is wrong. Same like that, some white is not black if I say, and many of you will agree that some black is not white, reverse also true. Can we go ahead with that one? So many of them will agree with that one. But here also I will prove that that is also wrong. See here, it's a very interesting one. I will explain each and every possibilities here, and accordingly we will move ahead. So finally we will find out what are all the rules there for implications and what are all the rules there for conversions, because these are all very important while converting the statements. So where in order to make proper alignment we can interchange the statements or we can convert the statements. That conversion and all, here we are going to learn it. Clear? First, now we are going ahead with the A statement. From A statement we will check I statement is true, O statement is true, and E statement is true, straight and reverse. Straight means same subject and predicate, reverse means a subject and predicate will interchange. Hope it is clear, right? First we will see how can we draw Venn diagrams for each statement. Then we will move ahead with the immediate inferences, that is implications and conversions. So see that how A statement can be represented in Venn diagram. Many of you, this one everybody will tell the answer, all white is black, right? Can I say this one also true? because same circle can be there, so white and black of same circle are overlapping, we can tell that this one also. So A type statement can be represented in how many ways, ma? 2 ways, right? Now come to E statement. No white is black, we need to mention 2 separate circles, or you can even interchange black with white, or top and bottom also you can put, but it won't make any difference. So E statement can be represented in how many ways? Only 1 way. But A statement, 2 ways. These are all very, very important. I don't think so you will be having any doubt here for this one and this one. Come to I statement. I statement, some white is black. Is it true? Some white is black. Is it true? Can I say some white is black? But this entire black that will come, some white is black, because other things also white is there now. So some white is black means this is also true. Can I say this one is also true, some white is black? No sir, how can that be true sir? You will say like that, because sir all white is black, how can you say that some white is black is true sir? Can't we represent like that? If you say no, you are wrong. This is right only. Why? Because if I say all white is black, in that some white is black is right or wrong, ma? If see that glass is full of water, somebody says some water is there in the glass, whether that is true statement or not. We need to tell that full of water, glass is full of water every time. No, some water is there in the glass, it is right only. That is reason this is also right. We will discuss in detail again, we will come back to that one. So this one again, same circle. So some white is black, can we tell that one? Based on same logic, we can tell that one also. Now I statement can be represented in how many ways, ma? 4 Venn diagrams. So remember 4 Venn diagrams. So finally we will come to O statement. Some white is not black. Some white is not black. Can I tell that one? Right? So some white is not black. Can I say like that? That is also right. Right? Not black means this area, some white is not black. Right? So can I say this one? Again a doubt. Sir, no white is black. How can you say some white is not black is true, sir, here? Right? So if no white is black is there, can't we say some white is not black? Nothing is there. Nothing is there. I will say something is not there. Is it true or not? Must say that I failed in all the subjects. We will say that he failed in some of the subjects. Is it true or not? Right only now. I failed in all the subjects, but my parents want to save my face. So before the neighbors or before the even relatives, what they will say, what happened to your results? They will say that so 1 or 2 subjects he failed, he will write in October or March, like that, and they will tell. Why? Because they want to save my face. Anyway, I am going to write all the subjects now. If I say 1 or 2 or only 1, it won't make any difference. That is the reason when nothing is there, something is not there is always true. This is also true only. So we will discuss in detail regarding that one again. Now you need to remember for each statement how many Venn diagrams are possible. So for A type statement, how many are possible, ma? 2. So 2 ways of representing A type statement through Venn diagrams. For E statement only 1. For I statement how many ways? 4 ways. For O statement how many ways? 3 ways. Now we are going to check from each statement what are all the implications and conversions we can derive, right? So now take the first A statement. My A statement, whenever we say that all white is black, can I tell all black is white is also true? Can I tell all black is white is also true? All black is white, here only it is true, not here, right? So in order to derive a conclusion, it must be true in all the diagrams. Then only we need to give a conclusion, or else we should not. If it fails in any one of the diagrams, we should not consider that one. Are you clear? If it fails in any one of the diagrams, we should not consider that one. So now say that all white is black. Can I say all black is white is true? It is true here but not here, but it must be true in both the diagrams, then only we need to consider. What does that mean? A cannot be converted into A statement. Clear? A cannot be converted into A statement. Now see that one. Can A be implied by I statement? What is the implied by? Means the same subject and predicate. Can I tell that whenever all white is black is there, can I tell some white is black? Some white is black, is it right? Some white is black, is it right? Again same doubt. Sir, whenever we are saying all white, how can you say some white? That is the reason I have given the example, right? So glass is full of water. Can I tell that some water is there in the glass? So whenever everything is there, something is there is always true. Always remember, whenever everything is there, something is there is always true. Am I right? It is right only now. So always remember implications. A is directly implied by I. A is directly implied by I. What does that mean? Whenever A statement is there, you can directly mean I statement is also there. I statement is already there in the A statement. So all white is black means some white is black is automatically right. Now we have confirmed A is directly implied by I. Can A be converted into I? Can we check that one? What is the conversion? Conversion of I means we need to take subject and predicate to be interchanged. So some black is white. Some black is white. Can I tell some black is white? Is it true here? Yes. So is it also true here also? Right? So whenever it is true in all the diagrams, it directly follows. That is how we need to take it. That means A can be converted into I statement. So now in immediate inferences, A is directly implied by I statement. A can be converted into I statement. Are you getting? So A can be converted into I statement. So whenever A statement is there, from A statement we can directly tell that some white is black is also true, some black is white is also true. It must be true in all the diagrams, then only we need to consider, or else we should not. This one always keep in mind. Now I part is over. See that from A can we derive O statement. What is O statement, ma'am? Some white is not black. Some white is not black. Is it true? No, right? All white is black. Some white is not black. Definitely not true. Here also ruled out. So A cannot be implied by O statement. What does that mean? A cannot be implied by O statement. Can A be converted into O statement? Can A be converted into O statement? Conversion means some black is not white. Some black is not white. Is it true? Yes, this is true only. But is it true here? No. That means A cannot be converted into O statement. It is true here, it is not true here. That is the reason we are not moving ahead with the O conversion, right? So A is not implied by O statement. A cannot be converted into O statement. But A is directly implied by I statement. A can be converted into I statement. A cannot be converted into A statement also. Why? Because all black is white is true here but not true here. Finally, which one we need to check, ma'am? E statement. So E statement means directly whether A is implied by E statement means what it will come? No white is black. No white is black. Is it true here? No. No white is black. Is it true here? No. Can we convert? Whether A can be converted into E statement? No black is white. Is it true here? No. No black is white. Is it true here? No. That's it. From A statement, what are all the statements we can extract, ma? Only I statement, right? So A is implied by I statement. A can be converted into I statement. Whenever everything is there, something is there is always true. Like that you remember. Everything means A statement. Something is there means I statement. Clear? Can we go ahead with the next one? Which is the next one? E statement. We'll go ahead with the E statement. No white is black. Whenever no white is black is there, can I say that no black is white is true? E reverse. No black is white is true. Is true or false, ma? True only. So whenever E statement is there, E can be converted into E statement, but A cannot be converted into A statement. Are you getting, ma? E can be converted into E statement. So directly I am writing whenever E statement, E can be converted into E. Now from E statement we will see that whether we can extract A statement, I statement, O statement as straight and reverse cases. So see that no white is black. Can I say that all white is black? No. All black is white? No. Some white is black? No. Some black is white? No. Can I say O statement now? Some white is not black? No. It's right only. What we discussed, when nothing is there, something is not there is always true, right? When nothing is there, something is not there is always true. So E is directly implied by O statement. E is directly implied by O statement. Clear? Can we take conversion of O? Can we take conversion of O? So E is implied by O statement. Can E be converted into O statement? See that what is the conversion of O? Some black is not white. Can I tell some black is not white? Is it true? Yes, that is also true. So E is directly implied by O statement. E can be converted into O statement. E can be converted into O statement from here and from here also. Why? Because no white is black, we can tell no black is white. We are telling some white is not black is also true, some black is not white is also true. So E can be converted into E and also O. E can be converted into E and also O. E is directly implied by O statement, that is the reason I have mentioned here. E is directly implied by O statement, E can be converted into O statement also. Now finally, E is directly implied by O statement, E can be converted into E statement as well as O statement. Very typical one more. You need to remember this E statement conversions properly. If you remember this one, you are almost through. Ma, are you clear? Now we go ahead with the I statement. Ma, I statement, some white is black, we have represented in 4 ways in Venn diagram method. Now see that whether I can be converted into I. Ma, what is I conversion? Some black is white. Whether it is true in this diagram, ma? Yes, because it must be true in all the 4 diagrams, then only we can give a conclusion as true. Right? So some black is white, it is true only. Some black is white, it is true only. Some black is white, yes, this is true only. Some black is white, yes, this is true only. I can be converted into I statement. I can be converted into I statement. Now see that from I whether we can derive A statement, A, reverse, O, E, all these things we will check. Now whether I is implied by A statement, what is A statement? All white is black. It is wrong. If it is wrong, if it fails in any one of the diagrams, no need to check others. Directly you can go ahead with failed only, so not required. Must see that all white is black, it is not true, no need to check others also because it must be true in all the diagrams. Now see that whether I can be converted into A. What is conversion of A? All black is white, that also fails, no need to even check, ruled out. So I is not implied by A statement, I cannot be converted into A statement. Now take O statement. Here many of you are having doubts, right? Whenever we say some white is black, some white is not black also must be true, sir, or some black is not white also must be true, sir. Everything I will prove wrong. Now see that one. Some white is black, we need to prove that some white is not black based on all these 4 diagrams. But some white is not black, is it true? Yes. Some white is not black, is it true? Yes. Some white is not black, is it true? No, right? All white is black, some white is not black is not true, ruled out. Here see that some white is not black. No, all white is black only. All white is black means we cannot say some white is not black. Here also all white is black, we cannot say that some white is not black. Are you getting why can't I statement can be converted into O statement? Means this is the reason. Are you getting? Because normally in day-to-day life we think that some white is black means some white is not black is also true, or some black is not white is also true. Very typical one, very interesting one, this syllogism. You need to understand the logic properly. So I is not implied by O. Can I be converted into O, ma? Some black is not white, that is true here. Some black is not white, ruled out, right? Some black is not white, true here. Some black is not white, ruled out. But it must be true in all the diagrams, then only we need to consider, right? So I is not implied by O statement, I cannot be converted into O statement. See that whether I be implied by E statement. See that here I be implied by E statement. What is E statement, ma? No white is black, ruled out. No black is white, ruled out. Even it is not true in any one of the diagrams also, right? So ruled out. Now I can be converted into only I statement. From I, what are all the conversions we have? My implications and conversions we have only one, that is I can only be converted into I. That's it. But before going ahead with the O statement, we will just sum it up. So A is implied by I statement, A can be converted into I statement. E is implied by O statement, E can be converted into E and also O. I can only be converted into I statement. How you can easily remember this immediate inferences, particularly implications, means whenever everything is there, something is there is always true. Whenever nothing is there, something is not there is always true. That means A is directly implied by I, E is directly implied by O. That one remember. Conversions, A can be converted into I, E can be converted into E and also O, and I can only be converted into I. Clear? Finally we will check for O statement. Must see that here also many doubts. Sir, whenever we say some white is not black, we can surely say that some black is not white is also true, right? This is what we have been thinking. We will prove that that is wrong. O cannot be converted into O statement. See here, some black is not white. It is true here. Is it true, ma? Some black is not white. All black is white, so we cannot say that some black is not white is true here. If it fails in any one of the diagrams, we cannot consider that, though it is true in these two Venn diagrams, but it fails here. That is the reason O cannot be converted into O. Are you getting, ma? So some black is not white, it is true here, it is true here, but it is not true here. O cannot be converted into O statement. Must see here whether O is implied by A statement. What is A statement, ma? All white is black. All white is black. Is it true? No. Here also not true. Here also not true. If it fails in any one of the diagrams, no need to check other diagrams as well. Can we see conversion of A? All black is white. All black is white. Is it true? No. Here also not true. Here it is true. All black is white. But we should not consider only one Venn diagram. It must be true in all the Venn diagrams. Then only we need to consider. So O is not implied by A statement. O cannot be converted into A statement, right? So now see that O is implied by I statement. So whenever we say some white is not black, some white is black is also true, like that. You may be thinking we are going to prove that whether it is true or not. Now see that whether O is implied by I statement. What is I statement, mom? Some white is black. Some white is black. It is true here. It is true here. Is it true here? No. Can O be converted into I statement? What is conversion of I, ma? Some black is white. Some black is white. It is true here. It is true. Is it true here? No. That means O is not implied by I statement. O cannot be converted into I statement. In order to consider, it must be true in all the diagrams. That one you need to remember. If it fails in any one of the diagrams, we should not consider. Finally, we need to go ahead with the E statement. Whether O is implied by E statement. What is E statement, ma? No white is black. No white is black. Is it true here? No. O is not implied by E statement. Can O be converted into E statement? What is conversion? No black is white. That also fails. What does that mean? O cannot be converted into any one of the diagrams. O cannot be converted into any one of the diagrams. That is the reason in 6 rules you are having A plus E, I plus A, I plus E plus A, E plus I. Nowhere you can see O, right? Nowhere you can see O. O cannot be converted. But you do have conclusion of O, but not in 6 rules. So that is the reason O can never be converted. O cannot be converted. Remember, O cannot be converted. That is the reason in 6 rules O is not coming into picture. That is the reason O is not coming into picture. Can we just recap one more time? See that this one is very easy, ma, implications. Because whenever everything is there, something is there is always true. Whenever nothing is there, something is not there is always true. That's it. In implications, only 2 we have. That is, A is directly implied by I and E is directly implied by O. Coming to conversions, A can be converted into I, E can be converted into E and also O, and I can only be converted into I. I can only be converted into I. O cannot be converted. A is implied by I, A can be converted into I. E is implied by O, E can be converted into E as well as O. That's it. So these are all the immediate inferences we have. Now we are going ahead with solving the problems.